Okay, hello dear friends, good evening. So, implicit. So in this video, we will learn about implicit differentiation. Differentiation. Implicit differentiation. So it happens in the implicit function. What is an implicit function? When we have y equal to x to the gazillion power plus 5x to the power of 3 plus a gazillion number, something like 189 or 108, any number. So you can see this y, you can get a crispy clear, an explicit number after you work the whole machine, the whole function. When you plug in an x, you get a y value. And it's very explicitly explained, represented, and you know it very explicitly. In Chinese, it's called 显函数. So everything is on top. For the y value, everything is very clear. You put in an x value, there will be a y value. And implicit is something hidden in. In Chinese, we call it 隐函数. 隐函数, 隐 is hidden, is hiding in the dark. Something like x squared plus y squared equal to 25. We know this is a circle, but here y value is kind of a variable. It's not very clearly. You immediately see a result like this one, right? Like this explicit function. This is an implicit function. Of course, you can change into y squared. You make an equivalent change, y squared equal to 25 minus x squared. And then you get y equal to positive negative root 25x minus x squared. And that becomes kind of an explicit function. Anyway, so today we are going to work on this implicit differentiation, implicit function, where x and y is mixed up together, two variables for us to figure out. So let me first, x equal to y squared plus 21. So we first, my habit, I put variable all on the right side, on the left side of the equation, and on the right side only the constant. So let's do the work. X minus y squared equal to 21. And after this, we will take the derivative. This function, this equation exists or established. And then the derivative also established, is equivalent. So we take the equivalent of x, the x equivalent of x, the x derivative, d over dx is 1. Oh, that's easy. And for y, we just take the derivative of y as if it's just any other variable. So it's 2, because here is 2, and 2y, y to the power of 2 minus 1, so y to the power of 1. And just remember, for x, you do not need to write down x prime or any number or any sign. But for y, you need to write down y prime equal to 0. And that is it. So y prime equal to 1 over 2y. So we find out the first derivative of y. y prime. Okay, now we come to this stage. The teacher wants to us to find y double prime, or the second derivative of y. So how do we see this? Now we see 1 over 2y. You can see, oh, this is a fraction. It's dividing 2y. So you can use quotient rule. And then just remember, the upper side is just the numerator is just a number. So we can regard it as 1 over 2 half of y to the power of negative 1. And then we take derivative of this number. It becomes much easier. So y prime prime equal to 1 negative 1 come to the top, so negative half of y to the negative 2. 1 negative 1 minus 1 is negative 2, and y prime, right? We bring in the y prime equal to negative half y to the power of negative 2 times y prime. This is y prime, 2y. 1 over 2y, so becomes negative 2 times 2 is 4, 1 over 4, and y to the power of negative 2, negative 1, y to the power of negative 3. We can write in a more viewable way, 1 over negative 1 over 4y cube. And that is the second derivative of y. Now we will do another one. Okay, now we do another problem. X square minus 2y square, x square equal to 2y square plus 8. Now I have a habit, as I have already said, I like to put all the variables on the left side. So x square minus 2y square equal to 8, right? I didn't change anything because I moved this one. 一项, you need to change the number sign, the positive negative sign. And now we take derivative of both sides. So for 2x, the derivative of 2x, the derivative of x square is 2 to x to the power of 2 minus 1. So x to the power of 1. So it's 2x minus 2y square. How do we do this? 2 minus 2 times 2 is 4. 2 times 4. And y to the power of 2 minus 1 is y to the power of 1. And y prime. And just remember, whenever there is x, you do not need to write x prime, y prime. And whenever there is y, you need to write down y prime equal to 0. The constant do not change. The constant does not change. So the derivative of the constant is 0. So 2, we can write this way, 4y, y prime, move to the other side, equal to 2x, y prime equal to 2x over 4y, so is x over 2y. So we find the first derivative, y prime is this. And the teacher wants to us to find the second derivative, double derivative. Now we work on the double derivative. The double derivative is to take the derivative of the first derivative, right? And the first derivative is a division, so we need to use quotient rule. Now let's see. We suppose a is x, so a prime is 1. Remember, whenever there is x, we do not need to write anything. And whenever there is y, we need to write y prime. So how do we find the derivative of x? Is x to the power of 1, so times 1, and x to the power of 1 minus 1, x to the power of 0, so it's just 1. And b equal to 2y. And now we take the derivative of 2y. And b prime equal to 2y. Y to the power of 1, right? 1 times 2 is 2. Y to the power of 1 minus 1 is y to the power of 0. Y to the power of 0. And whenever there is y, we write y prime. And y, 2 times y to the power of 0, this is 1, so it's 2y prime. Okay, now for this y prime, when we look for its double prime, we use quotient rule. Low d high minus high d low over low squared. So low 2y. D high times 1 minus high x. D low times 2y prime over low square, 2y square, right? So we clean up a little bit, becomes 4y square 2y minus 2x y prime. What is y prime? Y prime is x over 2y. Now we plug this y prime back in. So 4y square 2y minus 2x times x over 2y, right? Now we clean up a little bit, and the denominator we do not change, 4y square, and the upper part is 2y. 2y times 2y is 4y square minus 2x square. So, oh, there are so many 2's. We can first write it down and then we clean it up. Equal to 2y times 4y squared is 8y cubed, and 4y squared minus 2x squared. Now both divided by 2, so it becomes 4y cubed 2y squared minus x squared. So that is the second derivative of this function. Okay, we have found out the second derivative. We worked on finding first derivative, second derivative. Now this one, we will do it with a little bit complication, that is with x times y. Okay, so two variables times together. So the question is x squared plus 3xy plus 2y squared equal to 18. So the teacher asked us to find the second derivative, no, the first derivative, because it's just way too complicated. And usually we use math video for us to fall asleep, but if we do two second derivative, it just hurts our brain, and we cannot fall asleep. We just find the first derivative. Okay, so x squared, what is the x squared derivative? 2 comes to the front, x to the power of 2 minus 1, so x to the power of 1. And we do not need to write x prime or y prime because this is x. And for 3xy, we can treat it as 3 times x times y. So it's the product of x and y. So we use product rule. Product rule is x y prime plus y x prime, right? I'm a little bit confused with this xy, so we change a b prime plus b a prime, right? That is. So first we take its x derivative, so 3y, 3y, x to the power of 1, 1 times 3y is still 3y. X to the power of 1 minus 1 is 0, right? X to the power of 0, so it's just 1. Plus, now we take its y derivative because there is y in it. So y derivative is y to the power of 1, so 1 times 3x is still 3x. Y to the power of 1 minus 1 is 0. So this is 1. 1. We do not need to write it down. But remember, whenever we write down y derivative, there is y, we need to write y prime. Okay, for the 2y squared, we take this derivative. And there is no x, so we do not need to do product rule or quotient rule. It's y by itself. It is the same method as taking x derivative, only you need to write down y prime. So 2 times 2 to the power of 2, right? 2 times 2 is 4. Y to the power of 2 minus 1 is 1, just y, and y prime equal to 0. Now we combine the like items in according to y prime. So 3x plus 4y, y prime equal to, and bring this to the other side, negative 2x, negative 3y. So y prime equal to negative 2x minus 3y over 3x plus 4y, right? So now we find the y prime, the prime of this implicit function. Thank you very, very, very much. I think that hurts enough already. It's time to fall asleep. I love you. I really do. Do.